velocity component in x direction, which is u cos theta, into time of flight, so u cos theta into u sin theta plus u square sin square theta plus 2gh by g. So this is the value of the range of projectile. Now let's discuss the case when a projectile is thrown on an inclined plane, which is inclined at an angle alpha with the horizontal, and the projectile is thrown at an angle beta with the plane. So first let's see this animation. So here we can see that suppose this point is O. So OX is our inclined plane and OX is inclined at an angle alpha with the horizontal, and the projectile is thrown with the velocity u, which is velocity of projection, and the angle of projection is beta. And this is the angle which projectile velocity makes with the inclined plane. So to solve this projectile motion, to get various parameters of this projectile motion, that is the range, the maximum height, and etc., what we'll do is we'll consider our coordinate axis to be along and perpendicular to the inclined plane. So instead of taking our usual x and y axis, we'll take the x axis along the inclined plane, that is OX is our new x axis, and the y axis is perpendicular to it, so OY is our new y axis. Now we'll try to resolve our velocity component and acceleration component along x and y direction. So ux, which is the component of velocity along x direction, and the x direction is now along the plane, so this will be u cos beta ux, and uy would be velocity component perpendicular to the plane, u sin beta. Similarly, we have acceleration g. This will also have two components. The component along x direction, that is along the plane, would be ax is equal to g sin alpha. Now note that the direction of g sin alpha is in the opposite to the initial velocity. So if we are taking this direction, that is direction to the right of OY, as positive, the direction of AX would be negative, so AX would be minus g sin alpha. Similarly, AY would be minus g cos alpha, because direction above the plane OX is taken as positive and the direction of g cos alpha is below that plane, so AY is negative. So now we have the velocity and acceleration along x and y direction. Again, note that x direction is along the plane and y direction is perpendicular to the plane. So as we have already seen, ux is u cos beta, ax is minus g sin alpha. Similarly, uy is u sin beta and ay is minus g cos alpha. Now let's try to find out the range and time of flight of the projectile on an inclined plane. So to do this, first we'll try to write the equation of motion along x and y axis. So as we have seen, the motion along x axis will be given as x is equal to ut plus half at square, and u is the initial velocity along x direction, which is u cos beta. So we'll have x is equal to u cos beta into t plus half at square, where a is the acceleration along x direction, which is minus g sin alpha. So we'll have x is equal to u cos beta into t minus half g sin alpha into t square. Similarly, motion along y-axis can be given as y is equal to u sin beta into t minus half g cos alpha into t square. So first let's calculate the time of flight. So at the end of flight, the displacement along y direction is 0 because the projectile has touched the ground. So putting y is equal to 0 in this equation, we'll get 0 is equal to u sin beta into t minus half g cos alpha t square, or 2u sin beta by g cos alpha is equal to t. So this is our time of flight. So let's denote it by capital T. So time of flight is coming as 2u sin beta by g cos alpha. Now let's try to find out the range of the projectile along the inclined plane. So this is our range along the inclined plane. It is nothing but the displacement of the projectile along the inclined plane, that is along the x direction. So r will be given as uxt plus half axt square, and here t is nothing but time of flight, that is t, which is equal to 2u sin beta by g cos alpha. Now here ux is u cos beta and ax is minus g sin alpha. So now let's carry out this calculation. So we have r as uxt plus half axt square, where t is time of flight, that is 2u sin beta by g cos alpha. Ux is u cos beta and ax is minus g sin alpha. So let's put these values in this equation. So r will be equal to u cos beta into 2u sin beta by g cos alpha minus half g sin alpha into t square, that is 4u square sin square beta by g square cos square alpha. So we can cancel out 1g here. Now making the denominator of these two terms common, we'll get 2g cos square alpha, and in the numerator we'll have to multiply this numerator with 2 into cos alpha, so we'll get 2 cos alpha into u cos beta into 2u sin beta minus 4u square sin alpha into sin beta, which is equal to, again we can take 4 sin beta common in the numerator. So in fact we can take 4u sin beta common, 4u square sin beta common. 4 sine beta into u square. So what is left here is cos alpha into cos beta, and here it is sine alpha into sine beta, this is sine square beta, by 2g cos square alpha. So this is nothing but cos alpha plus beta, and we can make this cancellation. So finally we have the range of the projectile as 2u square sine beta into cos alpha plus beta by g cos square alpha. So this is the range of the projectile on an inclined plane. Now let's see what is the maximum range of the projectile along the inclined plane. For any given inclination angle alpha, the range will be maximum when dr by d beta is equal to 0. So let's calculate this maximum range. So we already have range r is equal to 2u square by g cos square alpha into sine beta into cos alpha plus beta. So now let's find out what is dr by d beta. This will be 2u square by g cos square alpha. Derivative of sine beta is cos beta. The derivative of cos alpha plus beta is minus sine alpha plus beta. So this term is nothing but cos beta plus alpha plus beta. So we have dr by d beta as 2u square by g cos square alpha into cos alpha plus 2 beta. So for maximum range, dr by d beta should be equal to 0, that is cos alpha plus 2 beta should be equal to 0, or alpha plus 2 beta should be equal to 90 degree. So this is the condition for the range to be maximum. So from here we can get the value of angle beta. This will be 90 degree minus alpha by 2. Now the value of beta is 90 minus alpha by 2, which implies that the condition for maximum range along the plane is that the projectile should be projected along the angular bisector of the angle between vertical and inclined plane. So let's see this in the figure. Now the angle between vertical plane and inclined plane is 90 minus alpha, because this is our inclined plane which is at an angle alpha to the horizontal plane, and the angle between vertical plane, this is our vertical plane,